Hello everyone, welcome to Practical GCP. Today I would like to talk about a new feature BigQuery has released recently called the slot autoscaling, which you might have heard about. And in this session I'll be discussing whether it's actually any good. So first of all, let's have a look at today's agenda. I'll start by have a reminder of the existing BigQuery cost models, which I've covered in one of the previous sessions, but let's just quickly go through that. It will be helpful to lead us into the autoscaling part. And what exactly is BigQuery slot autoscaling? And I'll then cover the slots reservation and the autoscaling itself in an example with a diagram, which I'll explain the different parts of it. All about the reservation and autoscaling. Then I'll show you a demo of how it actually works in BigQuery. So this is quite interesting because you can actually see the scaling happen as I query the data, and it goes up and down depending on how expensive your query is. So I'll show you that in the autoscaling in action part. And then I'll do a interesting one, which is a cost breakdown and some design thoughts based on based on the amount of data you may have and you may scan. And the design thoughts are basically how you might actually want to run to split, right, the different parts and combine different cost models of BigQuery. And finally, I'll summarize the whole thing with a bit of pros and cons and recommendations. Okay, so let's have a look at the existing BigQuery cost models we already have. The first three are the ones I've covered before. So we have on-demand, which is pretty straightforward. If you're just starting out with BigQuery, this is typically the one you would go for. It's a $5 for 1 terabyte of scan. So how much data you scan when you're querying the data. And then each GCP project has 2,000 slots. So keep in mind about that slot, right? This is slots, although you don't pay you do pay per scan based on data, but there's still a maximum amount of slots you have on a single GCP project, which is around 2,000 slots. You obviously have flat rates, which has the monthly or yearly commitments. So that's around $1,700 to $2,000 per 100 slots, right? Keep in mind that's slots again. That's only 100 slots. You see why I would like to break down the cost later on with something that is more comparable, but let's come back to that. Flex rate. So this is something I guess BigQuery introduced maybe 2 years ago. So this uses per minute billing, right? 60 seconds. And it's actually $4 per hour for 100 slots. And then finally, which is this new slot autoscaling thing, it's currently in beta and it doesn't support all regions just yet. It is also per minute billing, right? So it's not very clear in the beta. It says, this is how often it scales up and down, but I will show you the demo. You can actually see exactly what's going on in there. And then it's actually not $4. It's a bit cheeky in there. It's actually $6 per hour for 100 slots. I guess for anyone who have used Snowflake, which is a comparable data warehouse engine of BigQuery, it has something similar called the enterprise version, and that has something very similar, which is why I'm so excited that Google is now releasing this, which is more comparable between the two. Obviously, I think for both products, when you kind of ask Google or Snowflake to actually do this for you, there is a premium cost on that, so you don't actually have to deal with it. So the cost is quite a big difference though, so from $4 to $6 per hour for only 100 slots. But let's have a look at that a little bit more later on the cost side. So what is BigQuery slot autoscaling? So this feature allows users to assign a maximum number of slots for a reservation without purchasing any commitments, right? So you don't have to commit to anything. You use it, 60 seconds, it's gone, you only pay for 60 seconds. Autoscaling reservations are charged at an autoscale price when slots are being scaled up, and BigQuery scales reservations by multiples of 100. So you can't do 150, so it'll be 100, 200, 300, whatever, until it reaches the maximum number of slots. So this is it can't go over, right? So if you say this is the maximum it's going to cost me, then you set that, and then it's not going to break your bank. all the numbers needed for the jobs, right? So let's have a look at the slot reservation and auto scaling in a single diagram. So this is something Google has described in a kind of a single place. So at the very top, you have 1,000 annual slots commitments, right? So that's the one you already paid, which you have 1,000 and you can use whenever, right? And that's, you don't have to worry about, scaling up and down. That's just something already in the bag. On the bottom, let's break down into two separate parts. You have the ETL part, which is typical. You have, the ingestions, data transformations, probably overnight jobs, hourly jobs, and you have the reservations in there. On the right-hand side, you have typically peak hour, daily workload, dashboard showing to stakeholders or maybe other workload. But this one, you have your reservations in here. So the middle bit is the slot sharing. So what that means is even if you have reserved the slots on the left, they can be used on the right as well, right? So if they're not used, they can be kind of transferred and used on the right-hand side. So just break this down a little bit. The maximum reservation size of 1,300, which is the baseline slots plus the auto-scaling slots. So this is where it gets interesting. The baseline slots is the one that when you use it, right, you basically say, if you run any queries, right, for this kind of workload, you give it 700. So what that means is there isn't any waiting, right? There isn't any waiting. If you want to run any query, it can use that 700 baseline slots. So basically already reserved, runs 24/7, you'll be billed 24/7. So that comes out of your 1,000 annual slots as well. In this particular case, right? So that's 700. And then you basically say, okay, if my 700 is maxed out, right? Let's say you run a very expensive query that is scanning lots of data, and a 700 isn't enough. Then you basically say, and this can go for another 600 as a total of 1,300. So that's how this works. On the right-hand side, very, very similar. You have the total reservation of 1,100 baseline. You don't want a lot, you just go for 300. But because the different workload variations is quite a lot, you can say it can auto scale another 800 on top, which gives you a total of 1,100, right? So the things on the left can be taken to the right, as I mentioned previously, or the right can be taken to the left if they are not used. So that's if there's any slots that are idle, it can be shared in between. So this is basically how it works. So previously you didn't have the auto scaling, the baseline. You couldn't set this, right? You can only set the committed slots that you bought from the annual slots or monthly slots, but you can't just add this auto scaling bit, which is very, very handy. So this means if you don't know exactly how much you need, right, or sometimes your queries maybe run slower than expected, then you can actually use this to adjust the performance of your query to say, give it a little bit more and then it will run quicker, or give it a little bit less and it doesn't have to cost you that much, right? So that's how this works. So now let's have a look at the auto scaling action. So first of all, what I want to do is to show you the auto scaling configuration page on the capacity management. So you can see I have already created a reservation. So this one, I've done a auto scaling with assign it to a project to specifically tell it to use auto scaling instead. So, but in order to do this, what you typically do is you create a reservation, right? You give it a name, and then you choose a region, and then you can say either apply fix, which has always been there before, but this is the new one, right? This is the auto scaling one. You can see there's lots of different options. There are presets, right? And so keep in mind, right, the reason I keep mentioning about this 2,000 slots is because this is the maximum. Google said is approximately the maximum slots you can consume on a single GCP project, right? It's quite a lot of slots, but if you actually have to deal with hundreds of terabytes or hundreds of gigabytes or terabytes of data, it's actually not quite a lot. So you could easily run into contentions as well. So, right, so just keeping this in mind. So 100 slots is really not much in the sense of processing large amount of data. So you can see this is where you can get the baseline slots, right? So now if I don't put anything in there, you can see on the right hand side, is actually broken down. It's actually break this down into the cost of utilization of your 2,000 slots, right? So this is quite interesting. You can see it can cost you up to 21,000 per month if you only use 25% of the capacity, all the way go to 100%, which will cost you 87,000, right? This is like 4 times. It's quite a lot if you actually use the whole capacity. But if you don't use it, or if it's quiet times, imagine if you let's say if your workload is especially your ETL workload is very much on the like a few hours in the evening, so you might actually have a third of the day you're actually not doing much at all, if that makes sense. So that if that's your workload, you could actually save a third of the cost automatically just because of that. And then the rest, again, keep in mind, this is per minute billing, right? So if your job is hourly, right, if you can finish this job and there's enough slots, you might only do it for 10 minutes and then you save 50 minutes. So actually that is only 10 out of 60. So in terms of 1 in 6 of the capacity used. So keep that in mind, right? So this is not something you would use all the time. So depending on how it actually works in action, it might actually save you more than you expected. So again, this is the baseline slot I was talking about earlier. If you have 2,000, you can say I want 500, right, as baseline slots. Then you have the 1,500, which is your auto scaling part. So I've already created this before. And then here you can, once you've done it, you can say create assignment, right? When you create assignment, you can say which organization. You can do it at organization level, folder level, or project level, which is quite handy because if you have different departments, you might have different folders, then you might want to assign this auto scaling a reservation into that folder, so all of the project within that folder would benefit from this. So okay, so the next thing I want to show you is the actual monitoring page, right? So you can see I've been playing around with this today. So one of the main things I wanted to see was, if you look at the details in here, what I wanted to see was how quickly it can scale up and down, right? So this is from 0. I've given it up to 500 slots. So you can see it scales up and down very rapidly. So when I hit it with some really large query, it goes up, but when it's done, it scales down to 0 immediately. Keep in mind, when I set mine, I didn't actually give it any baseline. Because I didn't give it any baseline, it means there's absolutely nothing right there for you to run a query. So even you run a query for the metadata tables, information schema tables, that would still take like I think it's about 10 to 20 seconds. I think it's now scaled to 0 now, right? So let's just try one. I've got one of these queries. This is a very handy one that you want to keep this in your radar. So in the reservations, there's one called the reservation changes. So this tells you all of the auto scaling changes, right? So I've ordered it in a descending order, but this gives you all of the reservation changes, and with the 2 very important metrics, which is the current slots and the max slots, right? So you can see this keeps on changing. And if you look at one of the earlier ones, you've got 53, right? 2153 and 2156. This is actually going up, right? And then from 100 to 0, because I wasn't running anything at that point, is actually after a minute is scaled down. It's not exactly 1 minute, but sometimes it actually scales up and down in less than a minute interval as well. You can see this is 13 and then this is 1304. If you look at these 2 rows on the right, then you can see this is scaling up, right? So if you realize there's not enough resources, it won't just wait, right? It will just keep going up. So this one, it actually went up from 100 to 500 because I hit it with a query that requires 100 gigabytes of large scan with lots of aggregation. There was another one I did it with just direct table copy, which took a lot of resources out. So but then you see when it's finished, it's gone back to 0 again. Right, this is what I wanted you to see. But now I have 0 slot, right? If I want to run this, you see this is now running, right? But it's not actually doing anything yet. This query usually just takes like half a second or whatever. But now you see after 13 seconds, right? Okay, it's 14 seconds. Now it's finished. Why? If I run this again, you understand. Because this has just done a scale up, right? So I don't know if this monitoring how up to date this thing is, but yeah, there you go. I think it's a bit out of date. So now it's scaled up, right? So this is why. Because I have not used any of the slots for a while, so it actually scaled down as soon as that query is finished. So there's nothing in the queue, so it just basically scaled down immediately, so it doesn't cost you anything. So this is a very interesting behavior, and then you should make the most of this because it depends on your workload patterns. This can really save you a lot of cost, but you kind of have to get the slots in the right ways, so in the right proportions, or between baseline, especially between baseline and auto scaling part, because if you have zero baseline, what that means is whatever query you run, you're gonna have to wait, right? So it's 15 seconds wait. If you don't care too much, 15 seconds wait, and if you have lots of people using it, you might not need it at all. And keep in mind that if you don't have any commitments, the baseline, the baseline where you run 24/7. It will cost you the $6 rate, right? So which is quite expensive. But if you have any commitments, let's say the monthly or yearly commitments, and then that can consume those slots. Okay, now let's have a look at the next part, which is the cost breakdown and some design thoughts. So I've prepared this document here in a Google Sheet. Okay. This is where I want to break down the 2000 slots into a bit more detail between different price models. First of all, the on-demand, right? So this is not applicable because it's not easy to predict how much it's going to cost you on a monthly or yearly basis. So first column is the monthly cost, second column is the yearly cost. On the left is basically different kind of pricing models, right? So if you look at just flat rate yearly, if you put everything on flat rate yearly, for 2000 slots, it's going to cost you $34,000 a month and then $408,000 a year. Flat rate is monthly is similar, so it's about £80,000 difference in a year. And then you have flex rate, which is the the old, doesn't have the auto scaling. You can scale it yourself, but it's still a 60-second billing, but you have to make an API call, do the capacity planning, all of that stuff yourself, which going to cost you $59,520 a month, right? Which is quite a lot more. And then a year is going to be almost $250-ish thousand more than the monthly, right? So that's, but however, for the slot auto scaling one, which is the most premium in price, so that's going to cost you $89,000 per month, and then yearly is going to cost you just over $1 million. So now you keep this in mind, right? So what this means isn't mean this is just a disaster. It just means it's going to give you different options to do different kind of things. Because for slot auto scaling, you're never going to use it for a whole year, 24/7, right? That's not what this is for. It's for things that are, let's say, has a short. You have some schedules and you want to run this repetitively, or occasionally you have some really big job you need to run, scanning lots of data, but you don't really care too much about how long it takes to finish, right? So then the cost can be a main factor in that. Then, so here, again, based on the assumptions of 2000 slots, I've done a few scenario checks. On the left-hand side, you've got the processing size from 10 terabyte all the way to 1000 terabyte per day of scans, right? On the right-hand side, you have the monthly cost, right? This is just how much it's going to cost you every month. So based on the size of the scans of this much data per day. So it's quite interesting, right? The reason I want to do this is I want to show you how much on-demand can cost you if you do nothing about it. So this, it can cost you very, very little, right? Like 10 terabyte a day, $1,500, nothing to worry about. But then you started going up and up and up. So for 100 terabyte is already 15,000. You can see is half of the cost of the yearly commitment just to do 100 terabyte of scan, right? But this one, the equivalent, is basically you don't have any limits, right? To run whatever you want. This could be whatever terabyte for this month. But then it goes to 500 terabytes, and then you can see this is already cost twice as much of the yearly commitment one, and then the 1000 terabyte is a lot more, right? But obviously, it's not just simple math like this, because if you're going to have to scan 1,000 terabyte per day, 2,000 slots is probably not going to be enough. So later on, I did a bit of thought on how you might overcome that and how many slots you might actually need on different parts of it, right? So the interesting thing is, as I mentioned earlier, so the calculation in here is a little bit off because I used 31 days, and the other side, the Google calculator used some slightly different scale, but it's very similar, right, with the auto-scaling. So auto-scaling, because it has the 4 parts, right, so they're broken down into based on utilization. If your utilization is low, it's a quarter of your total planning, you can see in a lot of the scenarios, it can be cheaper than the yearly commitments, because you actually, if you use it like a quarter of the time in a day, which is actually possible, because some of this stuff like it depends, especially your dashboard workload, the weekend you might actually have 2 days for nothing, right? So it really depends on your workload. You have to try this out to see exactly how this plans out. But as you started getting into the 50% capacity, and this is already costing quite a bit more than the yearly commitment, which is kind of similar to the monthly commitment on the 50% capacity in here. But when you get to 70% or 100%, it's kind of it's like 1.5 or 2 times of the cost, right? So but with auto scaling, if you ended up with just hitting 100% all the time, you should really think about moving this to some yearly or monthly commitments rather than try to leave them all here, right? So that just means the balance is incorrect. So here I played some scenarios, right? So the scenarios are based on some of these things I've listed out, and are based on initially with 2,000 slots, but then later on there's more slots in there. So starts with the minimum cost, the maximum cost, and then the slots that you have. This is slightly incorrect because I've changed that. I'm just going to align these two. Right, so first of all, with 50 terabyte per day, 2,000 slots, minimum cost 0 because you might not have any scans, but the maximum is about 7,750. So for these two, there's not much like you need to worry about, but there is an alternative with the 500 auto. So this means basically give it 500 slots, right? And auto scaling, which is going to cost you this much. So it doesn't give you all of the 2,000 slots, but basically what it's basically saying is you can you use less of the utilization, right? You don't actually use all of it. You use less of utilization. And in here, this one, I think I better change that to 500 just to align these two, because of the estimation of the lower utilization that you'd need. So with 500 terabyte per day, 2,000 slots. So if you look at the 2,000 year commitment option, you basically throw it all in, then it's going to cost you 34,000, right? This is the minimum cost. The maximum cost is still the same, so right, because it's you throw all of these slots as yearly committed one. However, with option 2, you have a 1,000, so half of the yearly commitments, and then the other half you put it on auto scaling, which means the minimum cost is going to be half, right? So this is a lot less than the minimum, but the maximum is actually double, right? So it really depends on your capacity planning and the utilization percentage. Then it can actually range between these two numbers. Option 3 is you actually even lower the yearly commitments to a quarter of it, of the 2,000, and then give it 1,500 on auto scaling. You can see the minimum cost again drops into much less, but then the maximum has increased another 13K from the previous one, right? From this one. Right now, with the last two is because if you have to process this much of data, 2,000 slots is definitely not going to be enough. 4,000, I'm not even sure if that's enough or not, because it really depends on your P95, P99s, how much you can actually wait or you care about waiting. And then also keep in mind that you can actually if you see some certain patterns of certain projects, right, that has interesting patterns such as in the morning, you might need like 2-3 hours of auto scaling to, let's say, 10,000 slots, but only for 2 hours, Monday to Friday. That's very typical dashboard traffic, right? So that could be perfect if you just give it 10,000 slots, right? Not 4,000, but leave it for 2 hours, and then it will scale right down. But it's only for those projects because it won't actually need it for the rest of the day for that much. So this one is actually, giving a lot more slots. You can see the cost with 3,000 yearly commitments with 100 auto. Then it's going to cost from 51,000 to 95,000, and then the last one is 50-50 split. Then you can have a lower cost of the minimum, but the maximum go up to 100K, right? So that's 120K, right? So that's the kind of different scenario kind of played out based on the thoughts I had in mind on how you might be able to split. So obviously, whenever you have any yearly commitments, and these can be used in the baseline as well. So so if you use these on the baseline, then it's gonna give you more slots automatically. Can just use without waiting for the 15 seconds of auto scaling, right? So that's just what some of these options you have. Okay, let's summarize. So BigQuery Slot Autoscaling obviously can save cost optimization efforts. So what I mean by this is you don't actually have to get engineers or the FinOps teams to actually do a lot of this stuff yourself, because if you have to analyze all of the data, you have to look at the folders, look at different projects, it can be quite hectic work, right? So two is it can be used in combination with flat rates and on-demand pricing. So keep in mind, this is something you can apply on a folder level or a project level, right? So not every single project you have to use auto scaling or flat rate or on demand. You can do a mixture of everything, right? But if you don't want to, you can just apply some like a single theme on the whole folder level, which is probably a representation of the department, and then that can be it can save you a lot of time. You just juggle with the numbers to see what works better based on the utilization of the auto scaling. It can be very powerful for scheduled jobs and large in size, but not very time sensitive jobs. So this is the one I said earlier. If you have something like a job that you have to run for 2 hours, right, in the morning for dashboard, but it gets quieter after 10 o'clock because everyone kind of ended up made the decision and doing other things, which I've seen in quite a few companies. They have that kind of workload, which is very interesting that you can use this a lot. Or suddenly, if you have some large data you need to process, if you just do that on demand, it can cost you a lot. But if you actually don't care too much about the time, how long it take, then you can actually use this instead, right? So downside is not cheap, right? If you don't use it properly, it can really break your bank. It can cost a few times more than the yearly commitment price if you're not careful with this stuff. And if you're not optimize it properly, it can take a very long time for you to even run one single query, because if you don't put any baseline in there, as I mentioned, every time you run something, if it's been idle for a while, you have to wait for quite a bit. But if it's always busy, I guess it doesn't really matter too much. But that wait time can be a little bit annoying, but it does scale up, right? The other thing is when it scales up gradually. So what I noticed, it was scaled up to 100, 200, 300, 400 within about 20-30 seconds. So if you actually need to run something pretty big, then it might take like half a minute just to figure itself out before it actually does much of the execution. So that's where the baseline you want to think about to put a bit of just enough capacity, so you don't like get everyone to wait for ages trying to run their queries. And if you don't do this properly, it can make other job hang when all slots are used. So if you put 500 in there, if 500 is all used by one single large job, then all the other people have to wait because it's all queued, right? So this is like very important to keep in mind. It is in preview, so kind of make me upset it doesn't support some regions such as London. Can't use it just yet, which is a little bit annoying, but hopefully this will become GA soon and it will support all of the regions. It's important to take into account the total number of slots. As I mentioned, this 2,000 slots again, right? That's per project required when switching from on demand. So the 2000, the reason is very important is, let's say if you have a large organization, right, that you have quite a lot of teams that all operating in their own GCP projects, right? That means your total number of slots could be 10,000, right? If you're on demand. So when you switch into the auto scaling slots and with your yearly commitments, you can't just say, I'm going to put 2,000 in there, that will be enough, right? Even you have 8,000, it might not be enough at peak times, because one team can take away, like what it was before, it could have taken away 2,000, the other team taken away 2,000 at peak times. So you could very easily run into a competing situation if you have multiple teams all processing large amount of data at the same time. So this obviously you can easily avoid if you use on demand, where the teams all have their own project. They don't have any contentions. They don't actually, have to think about other teams, taking away their resources. So this requires still quite a bit of engineering when you switch from on demand to if you want to save cost. You have to kind of put into some effort and thinking what is the best thing that you can do to make this run a little bit better, save you cost, and also without actually affecting the team's productivity, right? That's very important. The last thing I want to mention is this estimate the slot capacity requirements. So this is a good page because it has quite a lot of useful information to, especially so the requirements, you kind of have to run your workload for kind of 7 days, right? So if you're running for 7 days, let's say if you always have busy traffic, this can actually gives you a lot of, let's say this one specifically, it can actually give you very interesting modeling in here. So the way to read this is if you add 100 slots, right, for the P99 or P100, what that is difference is gonna make. So if you give it another 100 slots, you see the top P99 is gonna move the slowest queries from 1 second. I think this is it seconds, from 1088 seconds into 801 seconds, right? So that's how to read this thing. So you can actually use this model to help you decide whether you should increase some of these slots in some of the areas or decrease some of the slots in some other areas. So very interesting page. I've not tried this myself, but I found this one as it seems quite interesting to actually, especially when you come to the optimization, all of this information is very, very helpful. And yes, that's it. And thank you very much. I hope you found this useful. I really hope this comes to GA. So we can also try in the London region to see how this can actually help us to save the cost in the time going forward. And yes, I hope you enjoyed it. Thank you very much. I'll see you next time.
Go out.